This is LIGO. LIGO is a huge scientific experiment which has just helped make what has been hailed as the biggest scientific discovery of the century by detecting gravitational waves. It's a moment few scientists across the globe had thought possible, but have been waiting for since Einstein's prediction of the existence of gravitational waves 100 years ago.
We have detected gravitational waves. We did it.
The discovery is huge. It's the first direct detection of gravitational waves and actually saw two black holes colliding and merging into one. It has opened up a new window of observation onto the universe, much like the first time Galileo pointed a telescope at the stars. And it's all thanks to LIGO. Yet did you know Scotland made significant contributions to the LIGO project, and there's even a retro-gravitational wave detector here inside Glasgow University from the 1970s. So let's go take a look. This is a split Weber bar. It's a gravitational wave detector, and this one here was built in Glasgow University by a design from Jim Huff. It's based on a principle from 1969 by American physicist Joseph Weber. So did this one ever detect a gravitational wave?
Well, we really don't know. We had one event between our two detectors back in 1972 that we could never explain. We thought at the time it might well have been a gravitational wave, but there were no other detectors running at that point.
So nothing could verify. So other than, this is limited by sensitivity, but also compared to LIGO, this is limited in what you can detect.
Oh yes, the strength of gravitational waves is measured by the strain in space. And this was capable of measuring a strain in space of about 1 part in 10 to the power 16. LIGO is capable of measuring a strain in space 1,000,000 times better than that.
The aluminium bar is a very early piece of technology in the field of gravitational research. It was a starting point for Professor Huff and his team, which led to decades of work, culminating in major contributions to LIGO. But what exactly did Glasgow do on the project? So the LIGO project was massive. It took a lot of collaborators, and this is actually maybe the most important contribution that Glasgow University made.
You're right, one of the key things that we've worked on is technologies to isolate the mirrors in the detector from sources of noise. And one of the ways we do that is to hang these mirrors. Those strings that you can see there are actually made again of very pure glass, ultra pure glass, what we call fused silica. And that suspension actually allows the mirror to hang very, very quietly, almost motionless, so that it's just waiting to respond to a gravitational wave coming.
So without this technology, you think it would be harder, if not impossible, to have detected?
That's right.
Yeah.
And that's really true. Again, in the first stage of the LIGO detectors, the mirrors were suspended just on metal wires. And the performance of that system, just in a single pendulum, really wasn't good enough. We wouldn't have been able to detect the signal that we detected at the end of last year. That wouldn't have been possible.
You've been in the field for nearly 40 years?
45 years.
45 years. So
a long time.
This detection was a remarkable moment in your life.
Yeah, it's really it's kind of the peak of my experimental career in a sense, you know, to have got there at last.
It's generations of people learning from the people before and taking that technology to where we are today, and that really is the start of a whole new branch of astronomy, gravitational astronomy. We're listening to the universe, listening to those vibrations come in rather than looking up at it.